All right, let's get going. Hi, everyone. Welcome to all of you, and thank you for joining the Roebling Museum celebration of National Engineers Week and Introduce a Girl to Engineering Day. We're really glad to have such a big group of students and parents and probably teachers for this presentation on women in engineering. My name is Martha Moore, and I'm a volunteer at the museum and I'm president of the board. We're going to be joined today by 5 women engineers who will tell us all about how they became engineers and what they love about it. And we hope it will be helpful for you middle and high school students who are thinking about what you want to study in the future. For those of you who haven't visited the museum yet, Roebling Museum is located in the historic town of Roebling, New Jersey, which is in central Jersey on the Delaware River. It was built in 1905 and it's on the National Register of Historic Places. Our museum is on the site of the former Roebling steel and wire mill. And our exhibits bring to life the story of the people who lived and worked in the company town, as well as the impact of the Roeblings and the Roebling Company. Now, why is Roebling Museum doing a program on women engineers? Well, because the very first woman in the United States to work as a civil engineer was Emily Roebling. Almost 150 years ago, when the Brooklyn Bridge was being built, she stepped up and completed the construction of the bridge after her husband, Washington Roebling, who was the chief engineer, became very ill. Without Emily Roebling, the Brooklyn Bridge wouldn't have been built. We have 5 panelists today. Denise Carter, a civil engineer who specializes in suspension bridges, yay. Judy Brown, a transportation engineer. Kira Pastor, a systems security engineer. Brigitte Livesey, a chemical engineer. And Sophia Pastor, a structural engineer. Each of them will give a short presentation and then answer questions. After we've heard from all of the engineers, there will be another little extra time for more questions at the end. I want to thank all of our speakers for their time and their expertise. And I also want to give a shout out to museum board member and Roebling resident, Tony Pastor, who organized today's program and lined up our panelists. Guess what? He's also an engineer. He's making sure that the Zoom goes smoothly and helping you if you have any trouble with the chat or connections or anything like that. And finally, I want to thank all of you who made a donation to the museum when you registered for today's webinar. Our programs since the pandemic have been pay what you wish, but every donation of any amount helps us with our programs and our exhibits to document and preserve Roebling's history. You can always make a donation to the museum by going to our website, roeblingmuseum.org. So, while the panelists are talking, you can submit a question just by putting it in the chat, and then when they finish speaking, we'll give them all of your questions. So our first panelist is Brigitte Livesey. Brigitte, are you ready?
I'm ready.
Brigitte Livesey currently works as a senior process engineer at Millstone Medical Outsourcing in Fall River, Massachusetts. Millstone provides manufacturing services for medical devices and pharmaceutical makers. Brigitte is leading the product launch for Millstone's first pharmaceutical client, and she led the successful manufacture of her client's product for use in phase 3 clinical trials. Brigitte has bachelor's and master's degree in chemical engineering from Rowan University in Glassboro. She lives in Norwood, Massachusetts with her husband, Chris, and their black lab, Frankie. Brigitte, are you ready to share your screen?
Yes, I am. Okay. Hi, everyone. I'm Brigitte.
Take it away.
And hi, everyone. I'm Brigitte, and I'm going to be talking about the types of engineering. So I'm from Roebling, New Jersey, but I moved to Massachusetts about 3 years ago. I'm currently living in Norwood, Massachusetts. I went to Rowan University in Glassboro, New Jersey, where I got my bachelor's degrees and master's degrees in chemical engineering. I really enjoyed my time at Rowan, and I would definitely recommend visiting the campus to learn more about the school. If you're interested in studying engineering, the engineering program at Rowan was really good and I enjoyed it. The class sizes are small, so you got to know the engineering professors really well. And I found the professors to be very helpful, and it's easy to get help from them. By the time that I got to my senior year at Rowan, all of the professors knew all of the chemical engineering students by name. So it was great to have that relationship with the professors and the other students within your program. Another thing that I enjoyed at Rowan was that we had the opportunity to start working on hands-on projects from our very first semester freshman year. And this continued throughout the rest of our time at Rowan. And I enjoyed that because it made school a little bit more interesting to be able to do some hands-on activities besides just sitting in class listening to lectures. After I finished my undergrad degree at Rowan, I stayed for my master's degree. And I did this because two of my professors offered me the opportunity to work on one of their funded research projects. So I was able to have my master's degree at Rowan funded through this research project. And I worked on a project that was funded by the Environmental Protection Agency, the EPA. And when I worked on this project, we worked with the DuPont plant in Parlin, New Jersey. And I designed processes for them to recycle waste chemicals that were generated from their process, as well as treat wastewater that was generated from their process. And this process that they were running was to manufacture a polymer that's used in microelectronics. And working on this project gave me the opportunity to work with people at DuPont and lead a team of a few undergrad students. It also gave me the opportunity to present at the DuPont site, as well as the EPA site in New York City. And I also got to present at a conference in Washington, DC. And I really enjoyed working on this project and learned a lot, which helped me with my career after I graduated at Rowan. And besides the engineering program, which I really liked, there were other things that I enjoyed about Rowan. There were a lot of activities to get involved with since it's a larger school. There's a lot of opportunities for things to do. There's a lot of different intramural sports. I played intramural soccer for some of my time there. And I also played club softball, which I really enjoyed because it was fun, but still competitive. We played a bunch of the schools in the area in New Jersey, Delaware, and Pennsylvania. So my current position that I'm working at, I'm a senior process engineer at Millstone Medical Outsourcing. And I'll talk a little bit more about my work as I go through the presentation. And prior to my job at Millstone, I was working as a process improvement engineer at Shiseido. And while I was in school, I worked as a process engineering intern during the summers at Johnson & Johnson in Fort Washington, Pennsylvania. I also have my engineer in training certification, which means that I can later apply and take a test to get my professional engineering license. And a professional engineering license. Maybe some of the other speakers will talk about some more later. But certain types of work that has a direct effect on public safety needs sort of like professional engineering sign off on. So my goal is to eventually get my professional engineering license. So the goal of my presentation is to talk a little bit about the different types of engineering. Hopefully you'll learn a little bit about the different types of engineers and the many different things that engineers do. So the main types of engineers are chemical, mechanical, electrical, and civil. But there are many other types that generally fall within these 4 categories, but are a little bit more specific. So some of the other types are biomedical, computer, industrial, environmental, but there are many other types of engineers. So chemical engineers, they use their knowledge of science and manufacturing to bring chemical processes that are developed in a lab on the small scale to an industrial or large scale process. And then once this process is set up, they'll work on troubleshooting issues that could come up and also make improvements to these processes. And these types of improvements could increase productivity and minimize manufacturing costs. And some of the industries that chemical engineers work in are obviously chemicals, but also fuels, foods, pharmaceuticals, biologicals, and many more. So an example of something that a chemical engineer would do would be, say, for example, somebody creates a new type of sunscreen. So they create this in a lab, but then they'll need a chemical engineer or team of chemical engineers to actually manufacture this, where they could supply, say, all of the Targets or Walmarts in the country. So they would need this help because when it gets invented in a lab, the person maybe can make, they're making a small quantity at a time. So chemical engineer would use their knowledge to set up the processes to make this in a larger scale, to make more volume so they could supply everybody who needs this product in the country or in the world. And maybe doing this, they need to purchase new equipment for where they're working. Maybe they don't already have the equipment needed to make this product. Maybe they come across issues where the way it's made in the lab in a small scale, maybe it doesn't work quite as well on the large scale, and some changes need to be made to make a large volume at a time. So at my current job, I'm working, like I said, at Millstone Medical Outsourcing. And what Millstone does is they manufacture medical devices and pharmaceuticals for our customers. So our customers are the actual people who are selling this product, but maybe they don't have their own manufacturing site, or they don't have enough equipment availability to make their own products. So my company makes the products for them. So for example, the project I'm working on to make a pharmaceutical for dialysis patients, my customer, they're a small startup company. They don't have a manufacturing site at all. So everything's getting made at my site. So for my project, I've been working on with them since my company first signed a contract with them. So I've had the opportunity to work on getting everything put in place to be able to manufacture our client's product. So at the beginning of the project, I worked on getting their manufacturing space set up. All of our product gets manufactured in clean rooms to maintain a clean environment for processing our product. So I worked on that. I also worked on getting all of the equipment in place, ordered, transferred to our site, installed. I also spent a lot of time learned how to use the equipment, and how to use it to make their product. And through all of that, through all the tests that I worked on, figured out the process for making their product. And now we are able to make their product, and we just recently made product for their phase 3 clinical trial. At my previous job, when I was working at Shiseido, which is a cosmetic company, I was also doing what's called process engineering, working on these types of processes, but it was a little bit different. I was working on processes that were already in place to package cosmetic products, but my main focus was improving these processes. So I was looking at what kind of issues were coming up on these manufacturing lines, and how they could be improved. So how we could reduce downtime on these manufacturing lines, reduce defects, things like that. So that's what I was doing at my previous position. So that's some information about the main thing that chemical engineers do. But as you'll see with all types of engineers, there really is a lot of different things that you can do. Some chemical engineers work more in the lab side of things, working in what we call research and development. So they're working more on creating new products in the lab, as opposed to helping to manufacture already created products. But there's a lot of things that chemical engineers can do, which is one of the things I like about it. So the next is mechanical engineers. So mechanical engineers design, develop, build, and test mechanical devices to meet human needs. They tend to work with anything that moves, from small components to machines to even the human body. And they work on a large scale size of different products. So they work on small components like sensors and switches to really large machines like cars, airplanes, spaceships, satellites. And some of the industries they work in are automotive, aerospace, electronics, biotechnology, energy, manufacturing, and more. So as you can see, there's a lot of different industries that mechanical engineers work in, and there's a lot of different work that they can do. I work with a few mechanical engineers, and at my company, the mechanical engineers, they do similar job function as me, but they're a little bit more focused on working with the actual manufacturing equipment. So if issues come up with the manufacturing equipment, they're the ones that everybody will go to. If we get new complex equipment brought in for a new project we're working on, they tend to be the ones to work with the equipment the most, to learn how to use it in case there's issues in the future. So the next type of engineering is electrical engineering. I'm not going to talk too much about this because I know one of our other speakers is an electrical engineer, so she'll probably give you more of a background on electrical engineering. But electrical engineers use the principles of electricity, electromagnetism, and electronics to design and develop new electrical equipment and systems to solve problems and test equipment. They design, test, and oversee the manufacture of electrical components for a variety of items such as computers, robots, cell phones, radars, navigation systems, and many other things. And they also could work on designing wiring and lighting in buildings and other kinds of electrical systems. So there's a wide range of industries that electrical engineers can work in, and the work that they do is varied. So the last of the main types of engineers is civil engineers. And I know that we also have speakers that are civil engineers coming up. So I'm not going to talk too much about it because I'm sure that they'll talk more in depth about it later on. But the main function of civil engineers is to improve infrastructure and common utilities to meet human needs. They design, build, and maintain all of the structures that surround us. So this is things like bridges, roads, tunnels, railroads, buildings, dams, and water and sewer systems. They also work on environmental problems, and some of the work they do is to improve recycling, waste disposal, improve public health, and reduce water and air pollution. And like I mentioned, there's a wide range of different types of engineers. Up here is a list of all of the accredited engineering degrees at colleges in the US. So there really are a lot of different types of engineers, and engineering is involved in basically every industry. So in summary, I hope that you got across that there's many types of engineers and many types of engineering work. And this is one of the things that I really like about engineering is it gives you a wide range of career choices. And as an engineer, it gives you the opportunity to solve problems and make improvements to our world. And that's it.
Thanks, Brigitte. That was great. We have a couple of questions in the chat. One real specific one is you mentioned that I think mechanical engineers work with the human body. And Pushpa Rajashekar asks, how do they work with the human body? What does that mean? What do they do?
Well, one example that I relate to at my job is that my company, we process a lot of medical implants. So those are kind of like joint replacements, pins, screws that are used for treating serious injuries. So all of those products are designed by engineers, some of them which would be mechanical engineers, because you need to understand sort of the how they work in the human body and the kind of stresses that are presented on those components. So that would be an example how they work with the human body. Mm-hmm. But maybe other areas would be keeping you safe, keeping your own human body safe. So maybe like airbags in cars and other kind of safety devices would also be working with the human body. So they're working with the outside, I guess, outside of the human body, and then within the human body as well. So hopefully that answers the question.
Thank you. That's great. So tell us how why did you choose to be a chemical engineer now that we know how many kinds there are? And what do you like about being an engineer?
Well, I chose chemical engineering because when I was in high school, I really liked my chemistry classes, and I also liked my math and physics. So that led me to choose chemical engineering. And what I like about chemical engineering is I like working with manufacturing processes, creating these processes, figuring out how products can be made. And one of the other things I liked when I first started college, I wasn't sure exactly what I wanted to do, but chemical engineering and other types of engineering too, they give you a wide range of career opportunities. So while you're in school, it gives you the opportunity to figure out what you like and go into that career. Or even when you first start working, figuring out what you like and then go more in the direction of what you like. So it gives you a lot of opportunities. You're not just stuck doing one thing. Like what I talked about is even just the main thing that chemical engineers do. That's not what every chemical engineer is doing. There's a lot of different options of things you can do.
That's great. Thank you. That is really interesting. So you didn't know, when did you decide you were going to be an engineer?
When I was in high school.
Okay. Great. Well, thank you very much. Our next panelist is Denise Carter. Denise is a licensed professional engineer with over 35 years of experience in design, program management, and construction management. She focuses on transportation and infrastructure projects in the New York metro area. She is the Executive Vice President and Chief Strategy Officer at Greenman Pedersen, Inc., an engineering consulting firm with 1,700 employees. As Chief Strategy Officer, Denise focuses on the best ways to grow the company and provide opportunities for staff development. Denise has been principal in charge for signature projects on all major suspension bridges in New York City, including the Brooklyn Bridge and the George Washington Bridge. And she's worked on many roadways, sites, parks, and coastal projects. She earned her civil engineering degree from Tufts University in Boston. She has 2 grown sons, and she lives on Long Island with her wife, Laura. Denise, thank you for joining us.
Thank you very much. Let's see if I can share the screen. Do that level of engineering would be good. Let's see. No, that's not really what I want to do. Hold on. Okay, can you all see that? Yes?
I can.
I can see a Word document.
Oh, that's not what I want to share. Okay. My apologies, forgive me. All right. I'm supposed to see the PowerPoint.
I think the PowerPoint was up for a bit and then it switched.
How about that? PowerPoint? Awesome.
That looks right.
Okay, we're good? Everyone can see me? Or see the screen? All right, thanks very much. All right, good morning, everyone. My name is Denise Carter. Thank you for that phenomenal introduction. I appreciate it. And I'm really excited to present for the Roebling Museum. I can tell everyone, full disclosure, I actually have a picture of Emily Roebling in my office. So I'm really excited to support the museum and the great work that they're doing to promote women in engineering. Thank you, Brigitte, for giving that great background. It's going to help me with my presentation. So, I thought I'd take this from like a very high level and talk about, very generally like what engineers do. Essentially, engineers develop new ideas and also solve problems, right? They make things better or come up with new ideas to really make every part of our daily lives better. So when you think about what you might have done as you came to this presentation, you got up and you brushed your teeth, and so the water that comes out of the faucet that came to you via pipes that were designed by engineers and went down a drain that goes into a sewer system that was designed by engineers. Even the quality of that water that you are using is being monitored and constantly looked at by engineers. And again, as Brigitte pointed out, things like toothpaste that you used or hair gel that you used or makeup that you may have put on, all of that really is connected to the engineering work that folks have done. Maybe when you had breakfast, right? So, you know, the stove that was used, the natural gas, the pipelines that brought that gas to your stove, the materials for the pot where you prepared your oatmeal, even the computer that you're using right now for this presentation, the hardware and the software was all developed by engineers. And, maybe later on today, you might go out to the mall, you might go shopping. So there was a site engineer that was involved in putting together the design for that parking lot. The buildings that you may go into, that was all developed by a structural engineer. Maybe you'll go out bike riding with your friends. The trails that your bicycle might be going on, those were all designed by engineers or considered by engineers. And, maybe you'll spend some time later on your phone. And there were software engineers that developed all sorts of applications that you all will be using. So next, I'm going to just detail some of the different types of engineering. And again, Brigitte did a really great job of providing an overview of sort of the 4 basic types. I'm going to start with the type of engineering that I am most involved in. So I am a civil engineer, and more specifically, I'm involved in transportation. So transportation is everything from, highways, bike lanes, looking at, how we use the entire roadway width for not just bicycles, but also pedestrians. How do we make sure that everyone is safe and protected? How do we make sure that things like trees are incorporated as part of the landscape? Making sure that we have the right traffic signals in place to keep everything moving and safe. Other areas of transportation, some of which I've been involved in. Obviously, as was referred to earlier, big bridges like the George Washington Bridge. Actually, we're working on a project up there right now. Working on making sure that the cables up there, the main cables up there are safe and strong enough to support the loading. This is a shot of the Holland Tunnel. Maybe some of you have gone through the Holland Tunnel and heading in and out of New York City.
Denise,
this is yes.
I'm so sorry to interrupt you. I think your slide presentation is not moving forward. We're still seeing the "What does an engineer do" slide.
Okay.
You may need to click the PowerPoint forward a few.
Can you see that? Technical difficulties. All right, I'm going to stop sharing and I'm going to try to share it again. I apologize for that.
No, thank you.
Can you see that? Hold on.
Yes.
Okay, now I have to be able to. Don't seem to be able to advance it for some reason. Can you see that?
Yes, I do.
Is that advanced?
GWB
Okay.
and Lincoln Tunnel. I see it.
Okay, fine. Okay, so there's the. I'll just keep going from there. So here we are on the Holland Tunnel. As I said, and that's a project that actually we're working on right now. So it's not just the sort of the roadway, but there are mechanical systems, electrical systems that are a part of that, and that's the work that we get involved in. And again, part of transportation engineering. Airports, really important. Not just there are the runways. There's the airport layout itself. Getting to and from not just your gates, but also to and from the airport, transit systems, rail. These are all part of transportation engineering, and again, all projects that I've been involved with. The photograph on the right I have not been involved with, but as a structural engineer, this is something that you can absolutely get involved with. And I'm told this is the Joker roller coaster, which is out at Six Flags. So I have not been on this, but if you're a structural engineer, this is the type of thing that you can potentially design. So again, Brigitte talked about some of the different types of engineering, and just very, very broadly. Someone asked a question about the types of things that perhaps the biomedical or the human body components may be involved in. You'll see on the upper left, that's called an ectoskeleton. This is something that is being developed to help folks that are paralyzed. Biomedical engineer and certainly electrical engineer, mechanical engineers will be involved with that. The Paralympics will be starting soon. So for those of you that follow it, you know, the prosthetics, that is like just an amazing area of work that many advances have been moved forward in. Even again, things like tennis rackets and golf balls, you know, materials engineers, you know, aerodynamics, all of that. And then we have 3D printed organs, again, that would fall under biomedical engineering. And, you know, in terms of problem solving, and you know, these are certainly issues that are facing our world and our planet today, looking at different ways to generate energy, sustainable energy via wind farms. Perhaps some of you have an electric vehicle, or certainly you've at least seen them. So new designs for not just the vehicle itself, but for powering those vehicles. Environmental engineering is certainly huge to make sure that plants and wildlife are protected from different toxins and pollutants. And coastal engineering, right? I'm sure many of you, you know, have been through or at least seen things of some of the storms that have been through. And so we need to make sure that coastal engineering is in place to make sure that the shoreline is protected. Again, all engineering. So I'm going to shift the presentation a little bit and make it a little bit personal. Talk a little bit about myself and how I grew up. You know, I was always fascinated by, you know, how things worked. Had a bunch of siblings. I grew up on Long Island, had a bunch of siblings, and you know, we would always, you know, take things apart or try to make things. So I guess I was like doing engineering even before I knew I wanted to be an engineer. We would always sort of take our bikes apart and put them back together, made little go-karts, built, you know, playhouses. My dad actually was a builder. And so he kind of instilled in us, you know, like figure things out. How do they work? You know, what can you do? And I'll say that this is all before like YouTube, you know, DIY, any of this. So a lot of it was really hands-on experimentation. I spent a lot of time right up the block from where I lived, was a really beautiful park. And so, you know, we, you know, would catch frogs and go fishing and stuff like that. So really learned to appreciate nature. That helped me to have an appreciation of the environment. And I also love sports, you know, played a lot of sports, and that was, I didn't realize, I found out later how important that would be in my career. A little bit on that in a minute. So, you know, I went to Catholic elementary school and high school, pretty rigorous academic curriculum. I was placed in an accelerated math program where I took 5 years of math in 4 years. I kind of kicked and screamed a little bit, like, but it was, I found it really interesting, right, and really helpful. I also took, you know, a whole series of science classes, including physics, and I have to say, like, I loved my physics lab. It was really, really fun. I loved the hands-on part of it. It was just really, really satisfying. I just really appreciate it. And I had actually my physics teacher, who I'm going to shout out, Mr. Ekus. He was really, I'd say, really instrumental in encouraging me to pursue engineering. And I also had a math teacher, Sister Miriam Jerome, I'll call her out, who taught me calculus and really encouraged me to move into sort of science and math-based work. Again, I was very involved with sports. And again, this was something that I found out later in terms of being on a team and the teamwork that was really, that I learned sort of just as I was involved with it. And later on, you'll find sort of as you develop your career, particularly in engineering, knowing and understanding how to work as a team. The individual ideas are really important, but learning how to be a part of a team. At times you have to lead the team, but that was sort of one of those nuanced skills that you wouldn't think sort of on its surface is really important, but you'll find out later on as you move into your career, particularly in engineering, how important that is. So sort of getting to my sort of junior and senior year in high school, I really wasn't sure exactly what I wanted to do. Neither of my parents were college educated, so they didn't really know a lot about the different sort of types of work that were available. And so I have to say that between my teachers, those two teachers that I named, and also the guidance office was really helpful in sort of supporting me into that decision making to move into engineering. And so I applied to a bunch of engineering schools and ended up going to Tufts University. So Tufts is located just outside of Boston. And it had a great engineering program, and I entered into the program sort of, you start off with sort of a general engineering curriculum, get your basics, the calculus, the physics, the sciences. We had to take a sort of like an intro course in each of the sort of main components of engineering: civil, mechanical, electrical, and chemical. I first of all, I'll say that it was kind of a shock to my system to go into engineering school. I will say that it was really a challenge. I mean, there was a period of time in my freshman year where I wasn't quite sure if I was going to, be able to make it. I mean, it was tough. And at that time, there weren't a lot of women, in the program. But I will say that that the women that I went to school with, we formed a really tight bond, and so that helped me along the way. But it was a challenge. I rose to the challenge. I got encouragement and support along the way, a lot from my professors, as well as my family and that group of women. And so I stayed with it. And once I got through my freshman year, you have to sort of make a decision about what type of engineering you want to go into. And so I was sort of on the verge of, I wasn't sure if I wanted to be an electrical engineer or civil engineer, but I sort of went back to my roots and thought about that building. And, I really like the idea of being able to see tangibly what I designed or what I came up with. And so I chose the route of civil engineering. So I graduated with my civil engineering degree, and sort of the first work that I got involved with was doing a lot of surveying, right? And so you all may have seen, surveyors out, on the side of the road or out as you're passing by different areas, and basically it's land measurement. So I kind of liked it, like it was like out in the field, it was outdoors. I really, really like that. And then, and basically what that is it's gathering data, right? And a lot of what civil engineering design sort of is grounded on is gathering data. And so sort of I got more into the design aspect of things, and I started sort of small-ish with some local roads. And again, it was a matter of sort of going out there, gathering data, taking measurements, observing how many vehicles move through a particular location, so you can get an idea of how wide a road needs to be, what the curvature of the road needs to be, again, so that it's safe, what sort of delineation you need to have out there and so that it's safe, what sort of sidewalk or, again, bike path accommodation you might want to put on there. And so I got involved sort of on the roadway side of things. And, I am going to sort of like fast forward a little bit, but shortly, thereafter, I sort of realized that my love and sort of my passion was getting involved with big bridges, and more specifically, managing the construction of big bridges. It came up in a bit of a flash on Brigitte's slide, but construction engineering is a component of engineering, right? Where, there are designs that are done and then it moves over into construction. And in construction engineering, that's where you ensure that what has been designed is actually built and built properly. And so I've had, the great joy and opportunity to be involved with some really significant bridge projects. The upper left is the reconstruction of the Tappan Zee Bridge. So the Tappan Zee Bridge crosses from across the Hudson River from Westchester County to Rockland County. The existing bridge that was there was old and deteriorating very, very rapidly. And so the decision was made by the state of New York to build a new bridge. A huge undertaking. I think the project was about $3 billion. So definitely something that was needed. And we were fortunate to be involved with that particular project. And just really a great project. It's open, it's built. And if you've ever been through that area, definitely, it's beautiful. It really turned out really, really beautifully. I've had the opportunity again to work on the Brooklyn Bridge. Walking up, the only way to get to the top of the tower of the Brooklyn Bridge is to literally walk up the cable. And, it's a little bit nerve wracking, but it definitely gave me a real appreciation for Emily Roebling and the work that she did. And then on the lower right is the reconstruction of the Bayonne Bridge. Again, that's in New Jersey. Some of you may have been on it. But if you can see that girder there, like you can literally like walk through that girder. It is an enormous project. And again, that wrapped up a few years ago. So, working in the civil engineering field and more specifically in transportation has been extremely gratifying. I get the opportunity to work with many people where we envision the projects. We get input from the community. We get input from other engineers. We get input from our clients. We make the decisions in terms of what would be best to solve the problem that is presented, whether it's, a bridge is deteriorating, or maybe it's not wide enough, or maybe there are some, condition issues that need to be addressed. I get to work with really, really great people. A couple of people that I work with are on this call even, which makes it really cool. And no one does anything solo, right? It takes a team. And so it's been my pleasure and my honor to be able to work with a team of engineers on many projects. I'll say that now at this point in my career, I'm less involved sort of with the hands-on of the projects, and I'm involved now with the business aspect of it. So, the arc of my career has gone from counting cars and doing surveying, being involved with some of the designs of many different things that, folks get the chance to drive through or drive over. I've had the opportunity to be involved with building a number of these really, really important projects. And then, now I'm sort of, I'm in a position where I can get involved with sort of the business aspects of it, which is a little different. But, it gives me the opportunity to identify, what areas that we want to continue to get into, how we want to hire people, how we want to shape our staff. And that's just a whole other area of the work. And so if you're thinking that engineering is just numbers or it's just lab work, it's like, yes, it can be that, but it can be so much more. And so, I am a huge fan of the engineering profession. There's so many different things you can get involved in. Ask a lot of questions, talk to different people. I think forums like this are super helpful to just get an idea of, what the different things are. And I know that there are other really, really smart and accomplished women that are on this panel that'll talk about some of their experiences. And so with that, I'll wrap up. And if anyone has any questions, I'm going to figure out how to stop sharing my screen and not mess up. So thanks for that.
Denise, thank you. That was such an interesting presentation. One question coming in from the chat is, do I have to be a straight A student to consider engineering as a career?
That's a really good question. And I'm going to say the answer is no. You do not need to be a straight A student. I will say, and I think everyone on this panel would affirm that it is a challenging curriculum. There's no question about that. In some areas I had to work really hard. I'm thinking of one math class in particular that I just could not get. And I had to I started it and I had to drop it. I started it and I had to drop. I just could, it was just something in my brain I just could not get. And I eventually, got through it. But I wouldn't let, being a less than A student deter you from pursuing it because it can be just really, really great.
Here is a good question from Kirsten Ebersol. She says, I really think that I would like to be an engineer, but I would really like to avoid a job where I'm typically at a desk or computer. Are there other certain types of engineering that would be better than others for this?
Yeah, so actually that was something that honestly surprised me a little bit when I got out of engineering school, because I'd say probably for the first year and a half, I spent most of my time out in the field, and I was like, wow, this is great. So again, the data collection piece and the condition inspection piece of civil engineering, I could speak to in particular. Going out with these contour maps and kind of walking through parks and things to identify sort of where trails need to go. It is very much, I'll talk about civil, it's very much a discipline where being out in the field or outdoors is really an important component of it. So I wouldn't let that concern about only being in front of a computer, be a deterrent.
Okay, quick question. Are internships part of undergraduate engineering programs?
So depending on the school, there are some schools that have very, really well-developed, well-established internship programs. I'll give one as an example. Northeastern University in Boston, their engineering program is actually a 5-year program, but they weave in these externships or internships, I don't remember what they're called, but where they actually have connections with different firms in industry, and you will take some coursework, and then you'll go and you'll work at a firm for long, not just the summer, it's maybe 4 or 5 months, and then you go back to school. So they're on a little different pattern, and it's a great opportunity to get sort of some experience. And sometimes it's more important to know what you don't want to do than what you want to do. So sometimes just trying something and using the process of elimination to say, that's not really something that I'd like to do. But other than Northeastern, there are other colleges that, I'm sure have different internship programs. And I'll say that a lot of companies reach out very proactively to engineering schools to pull in interns, right? Because it's great from a company's perspective to sort of, try on different engineering students to see how they work, and then eventually hire them on once they graduate from their school.
I know you can't stay for the whole program, so I got to ask you this now, because this is Roebling Museum, and I would be totally remiss if I didn't say, so Denise, what is it about those big suspension bridges that you love so much?
I just marvel at them, they're really complex systems, right? But yet they're so simple. Someone came up with this idea of just hanging a tray on a string, basically. And I'm sure all of you have had the experience of being stuck in traffic on a suspension bridge, and you feel that movement, you feel that wait a minute, this feels a little weird. And I have to say, the genius of the folks that designed these suspension bridges, whether it's the Roeblings or Ahmar Amin that designed the Throgsneck Bridge and Verrazano bridges. I mean, I don't know. they are engineering marvels. So I just love being involved with them. And when you go to the top of those towers, boy, you really feel small.
Thank you so much. You're terrific, and we really appreciate your taking time to do this.
You're very welcome.
Our next guest, I feel like a talk show host. Our next panelist is Sophie Pastor. She is a junior engineer in the structures department of Greenman Pedersen. Am I saying it right, or is it Peterson? She inspects a wide range of structures from traffic light mast arms to bridges on the turnpike that are over a mile long. Her recent project include load ratings for the Route 495 bridge to the Lincoln Tunnel. She has a bachelor's in engineering from Rutgers, and she's currently completing her master's degree in structural engineering, also at Rutgers. Thank you, Sophie, for taking time to talk to us.
Hi, let me share my screen. Okay. Okay, so I'll be talking about engineering in high school, college, and just a little bit beyond. Here's a picture of me from college graduation, which unfortunately were the pictures in my backyard since it was during COVID. And then here's a picture from, I think, November or December of me inspecting the Parkway Bridge over the Raritan River near Perth Amboy. So just a little bit about me really quick. I graduated from Rutgers in May of 2020 with my bachelor's degree in civil engineering. And I've been slowly finishing up grad school at Rutgers, and I'm hoping to graduate in this May. And I'm doing my master's degree in structural engineering. And then throughout college, I was a part of some research programs. I spent a summer researching like train safety. If you think like about the high speed rail lines that go really fast, they actually create like a vortex that can pick up the rocks that line the side of the train tracks and could like hit people. So it was about that, which I never really even had thought about. And then I also worked in a concrete lab where we would be mixing and testing concrete in like small cylinders and huge 20-foot beams. So that was really fun. And then for my master's degree, I've been doing research of fatigue testing of a bridge deck sample. You can see that on the right side of the screen. This is what I built and designed, which was really cool to go from like designing it in CAD and then having the pieces manufactured and actually physically putting it together. There's the center of the screen, you can see there's like an actuator that pushes force down onto our bridge deck sample. And then I also had 3 internships throughout school. And I guess someone asked a question earlier about internships, and these like weren't required, but definitely added a lot for my education, I guess. Because as you can see, I worked at a structural engineering firm, a site design firm, and a geotechnical firm. So I wasn't totally sure what type of civil engineering I wanted to do. So doing internships in the different fields gave me a better idea of what that would be like, rather than just relying on like classes, which like I had classes about geotechnical and structural, but site design, which would be like designing drainage and runoff for say like a parking lot or you're building a warehouse, isn't really covered at school. And then I've been working at GPI since May 2021 when I graduated school. So I'm currently working in structural engineering. So I'm also in the bridge inspection group at GPI. And here's a picture also still on the Parkway of us in the UBI, the underbridge inspection truck. And you can kind of see there's like a big truck on the highway and it has this like really long arm that we use to get under the bridge. It's really cool. And so we're out on the Parkway. We do like some bridges on the turnpike. We do some private bridges. We did one on like a old Merck campus. We also are working on traffic lights, which I never really thought about someone inspecting them, but it makes sense since they're over all that traffic. It would be really bad if something were to happen. And we just started a new project for minor bridges that are less than 20 feet long. So that's really fun because they're just like hugely different than these huge parkway bridges. You can do multiple in a day. And but it's still the same idea of like looking at the different parts. It's just on a huge different scale. And then I did some proposal prep for parkway bridge rehabilitations. And I spent a couple months working on load ratings for the Route 495 viaduct. This was interesting because it was built in 1938. And the load ratings are just comparing like what the bridge can handle versus what it like needs to. And so since it was in 1938, we have to look through all these old documents to try to figure out the what like parts were used. Because I don't know, you can see the bridge in this picture, everything looks so uniform. This bridge is just like thrown together with all these different parts. And it's cool because it's really busy. It connects a turnpike to Lincoln Tunnel. So like there's always people on the bridge. So the construction of it seemed really interesting. My manager was telling me about it, but it was before I started working. And also like someone asked, I really like this job because there's a lot of field work I can do. I really love not being at the office and just like being in the field. And here's some really neat pictures from the middle two are from the turnpike. You can see we literally had to walk alongside the inside of these girders where it's like maybe a little over a foot wide. We're roped in, but it was really, really neat to be like suspended over the river. And we also have really great views of the skyline. And then this was a really cool week out on the parkway where to get to some parts we needed to use a man lift on a barge. And you can see there's like the boat with the barge on it. And it was just a really, really unique experience. And so obviously there's still office work because you're in the fields taking all these notes, but then you have to go back into the office and write the actual report. But I really liked that because it gives you a good time where like you can be in the field for a while. And then when you're finished up, you go to the office for a little bit and work on the report. So it's a good mix of being in the field and being in the office. A little bit good this year because we finished up right before winter. So we're spending winter in the office, but I don't think it always works out that way. But that's something that I really love about doing bridge inspection. And there's not like that many jobs where you get to like climb around on bridges. And so since I just graduated, I can talk more about how I started thinking about engineering in high school. These are the classes I took mostly, but I think that liking math and physics is your biggest indicator that engineering could be for you. I always thought that math and physics were my favorite classes in high school. And so it just made sense. And I also, like Denise mentioned, I like doing something that I can see and visualize and understand, whereas I don't really understand like how Wi-Fi works. And then I also thought a really important part of high school was taking AP classes if your school offers them. It kind of wasn't fun to be taking harder classes in high school than my friends and having to do more work and like study more, but it ended up definitely paying off because I had time in high school. And then in college, I got to place out of these classes that were like designed to be hard and to make you think like, oh, engineering school is going to be this whole like daunting task. And like, so my friends were taking Calc 1 in this lecture hall with like hundreds of students, but I started in Calc 3 because I had taken AP Calc. So that was like a big difference. And then since I got to place out of classes, I could take fun classes. I did a minor in philosophy and I took some other like classes that I didn't really need to just because I had to take more credits. And that definitely made it really fun. And then I guess throughout high school also, it's important that you study for your SAT or your ACT because you do need to do okay on those to get into like engineering schools. And then it's also good to think about your engineering specialty. Like I took these classes and thought about it, and I was like, I took bio, but I didn't love it. I don't think biomedical engineering would be for me, and the same with chemistry. And also, I think English was more important than people thought. It's definitely important to be able to write papers. And then these are just some examples of college classes that all the engineers have to take. And in the right, this is like a classroom that I had most of my classes in. It's in the new engineering building at Rutgers. It was really great. There was chargers at every seat and like outlets. And it was a really cool learning environment. I just wanted to throw that in there. So I took all these classes and I put asterisks towards the ones I use at work a lot. You can see it's not most of them, but it was definitely gave me a good background. And I think like technical writing is also definitely super important throughout. And I just I don't know, it can seem daunting like thinking about all these classes, but all you really needed to get was the general idea for most of them and then kind of move on. Like I took fluid mechanics, it helped me with other classes, but I don't need to know about water particularly. And then these are more specific engineering classes like AutoCAD. And then I took classes in all the different specialties like construction, structures, transportation, soil, like, yeah, that's pretty much it. But then also I got to take a lot of fun classes. I took Planet Earth. I took earthquakes and volcanoes, history of rock and roll. I took a couple logic classes. And I thought they were all really neat. This picture on the right is from Reinforced Concrete Lab. For class, we had to design this beam. We had to design the rebar on the inside, the concrete mix, build the rebar cage, mix the concrete, make the whole beam, and then test it in the lab, which was really cool. Ours didn't do well. I think our professor, our TA led us astray a little bit. But so when I was thinking about college, I was, like I said, like I really liked math and physics, and I really liked problem solving, which I think is like a larger part of engineering than most people think. It's definitely mostly problem solving. Like you go to high school and college to kind of get this background and like a general idea of like, okay, I know how physics works sort of, and I know some math, and then how can I apply this to the problem at hand? And I applied to mostly schools in state that had engineering programs like the ones on the right. But I really liked bigger schools like Rowan and Rutgers because they had a lot of options. Like in case I wasn't sure what I wanted to do, I wouldn't be stuck doing engineering. Like if I had gone to Stevens, I would have had to do engineering. So that would have, I don't know, just as a toss up. And then you also can definitely start at community college and then transfer. I know a lot of people who did that and it worked out really well from them. It's kind of like you can ease into college more so than just being in a new situation. And so also when you're thinking about college, you have to kind of think about the difference between larger schools and smaller schools. On the right is a picture of a lecture hall at Rutgers. At the bottom is a classroom at Rowan. And like, not to say I didn't have classrooms in like a smaller class, but most of my classes were like 90 people. The only classes I had that were smaller were my philosophy minor classes. Like every single civil engineering class had 90 people, but I liked that. It meant that I had a lot of opportunities. There's like literally hundreds of clubs I could join. So many alumni who helped me get internships. But like I definitely had to put in more work to do that. And I know other people who just kind of, the school's so large, they never ended up doing anything. And Rutgers also has a ton of different engineering majors. You even can do applied science and engineering where you get to choose all of the classes you take and it's like your own degree. But then if you go to a smaller school, like Brigitte was saying, like your professors will know you and you know all your classmates and you can stand out and it's less overwhelming. But I think if you're pretty confident in yourself either one would be great. And at Rutgers, I was in an honors program. And so I had some classes that were honors classes that would have been large, but were smaller because I was in an honors section. So working hard in high school definitely paid off greatly in college. And I think that a lot of people don't think about that. And like, you don't even need to have great grades, but just like really trying your best will make it a lot easier. And that's all I really have to share. Oh, and I see there's some questions.
Yeah, thanks, Sophie. Here, I'll just in case not everybody is accessing the chat. So Caitlin Lyman would like to know, what kind of classes would you recommend for freshmen in high school that would help for a possible engineering career in the future?
Well, it depends at your like high school, what order your classes go. But I think it's important that you take physics for sure. And then just as many math classes as they'll let you. I think I took like algebra 1 and geometry at the same time or something like that. So it's definitely kind of trying to be like, I want to take math classes, I want to take physics classes, and then whatever else you can fill in as well.
Mm-hmm. So what about extracurriculars? Isha
For people interested in biomedical engineering.
Yeah.
Well, my favorite extracurricular in college was the radio station. I'm not sure that really helped with engineering, but it was really fun. And like, you can still do really fun stuff while you're in engineering. I think for biomedical engineering, a lot of those people want to go to med school. And if you want to go to med school, you have to do specific extracurriculars like volunteering at hospitals and joining like biomedical clubs and stuff. But I think if you're a high schooler, it'd be a really good idea to volunteer at a hospital. I know I did that in case I wanted to do like biology type things, but I ended up changing my mind. But there's also like the Doctors Without Borders and other clubs where you can, and Engineers Without Borders seems really cool, where you can help out people overseas.
Great. Thank you, Sophie. Our next speaker is Kira Pastor. She's a systems security engineer who is part of the Information Technology and Security Compliance Group at Chubb, an insurance company in Philadelphia. She works with project teams to find technical solutions to fix vulnerabilities in Chubb's software. Kira previously worked as a systems engineer at a defense contractor, where she worked on cybersecurity for autonomous unmanned vehicles. Kira earned a bachelor's and master's degree in electrical engineering at Stevens Institute of Technology in Hoboken, where, among other honors, she was head of the knitting club. She lives in Philadelphia with her fiance, David.
Thank you for the introduction. Is my audio sound okay? And can you see the slides?
Yes.
Okay, I'll get started then. Okay, so just here's a quick agenda of what I'll get into today. I'll do an introduction for myself. I'll give you my reasons why I think you should become engineers. I'll give you some examples of what I'm calling non-standard engineering career paths. Then I'll give you, Martha said I'm a systems security engineer. So I'll introduce what systems engineering is, and then I'll talk about how cybersecurity plays into engineering. Like Sophie, I also grew up in Roebling. I'm a member of the museum. I went to Stevens Institute of Technology. It's in North Jersey, right across from Manhattan. I studied electrical engineering. I got a bachelor's degree and a master's degree from there. I graduated in 2016. Shameless picture of my dog Nutmeg. And for anyone who lives in Roebling or Florence, this is her at the Patriotic Day parade this past year. Okay. So here's my reasons why I think you all should become engineers. So kind of like Sophie said this, right? Engineering, it's really about problem solving and even like creativity, right? Like my side hobbies, I really like knitting and crafting and, sewing and building solutions and those kind of interests of mine really translate well into engineering, because you're in your day-to-day job, you're trying to solve problems and come up with creative solutions. I like it because the work is challenging. It involves continued learning. No matter what type of engineer you are, you always need to stay on top of whatever the latest technology is. Like you could think about it, if you're a software engineer, right? Computer languages change continuously, different programs change, so you always need to be willing to learn. But that's part of what makes it exciting. So pros and cons. I also think it's really good if you're someone who wants to make a difference, right? If you're someone who wants to fight climate change, right? Engineers build solar panels, they build, wind farms to gather energy. What if you want to work in or with the armed services? If you want to be in the armed services, they'll pay for your college. I know a lot of people who do that and currently, work for the Navy at the Navy Yard in South Philadelphia. And like at my previous job, I was a defense contractor. So we built systems that the US Navy used. And we actually built systems for like the Australian Navy and other countries like that. And in general, engineers are creating technologies that improve lives. You could think about, I don't know, anything you use in your day-to-day life is probably built by an engineer. So you can have an impact on people's standard of living. Other pros that you might not be thinking about this if you're in middle school, but engineers have really flexible work hours, work locations. I currently work from home. A lot of engineers work from home if that's something you're interested in. But on the other side, there's a lot of travel opportunities. You saw that Sophie works a lot in the field. I used to fly a lot across the country to go to different Navy bases and talk to customers, see how our products are working. So I went a lot out to, California, Massachusetts, New Orleans, different places around the US. I know a lot of people who went out to Australia and other countries for projects too. And my last point, there's a huge variety of career options if you study engineering in college, and a lot of them are outside of the standard engineering field. You can see I studied electrical engineering in college, but I never actually was an electrical engineer once I started working. I worked as a systems engineer. Now I'm working in cybersecurity, and there's a lot of people who study engineering and then work in kind of an adjacent field. So I'm going to move to my next slide. These are some examples of adjacent fields where engineers work. Medical industry, some engineers will go off and become doctors or, work with, other, like in labs and other parts of the medical field. They work in banking, business, software development, people who are building, apps that you use on your cell phone, that kind of stuff. Program managers and project engineers, a lot of engineers will work in the field for a few years, and then they move into management where they're more focused on, budgets, managing people, that kind of aspect. Engineers become teachers. One of my favorite teachers in high school studied engineering. Or you could be like me, I work in information technology right now. And there's also a lot of engineers who are small business owners and work for themselves. Okay, so now I'll get into what systems engineering is. So my first bullet point, that's the Wikipedia definition, how to design, integrate, and manage complex systems over their life cycles. It's kind of nebulous, hard to understand what that means. So I'll try to give you an example here. So say you're working for a company and they're trying to build a new car, right? The company starts, they have a proof of concept, kind of what they want the car to do, kind of how they want it to look. And from that point, systems engineers come into play and they take that design and they start breaking out into more details, maybe building a model, building a picture of how it looks, getting an idea of what kind of like fuel, what kind of mileage they can get for the car, how far they think it can go on a tank of gas, how fast it can go, how much it's going to weigh. They start building out the design, right? And then at that point, systems engineers, they pull in the other engineering disciplines and start divvying out work. So they're going to work with the mechanical engineers and say, hey, you guys need to build this chassis to meet this design. It needs to be able to be, have a certain strength properties, things like that. Then they'll work with the electrical engineers and say, hey, you guys need to build the electronic system for the car. It needs to have this kind of user interface. It needs to have a touch screen. It needs to be able to send signals to these other components in the car. Maybe they'll work with other engineers who build, the outside, the housing of the car, make sure it's aerodynamic, make sure it's fuel efficient, right? As the project continues, the systems engineer still oversees the other disciplines, making sure everything works together, making sure they're building the car per the original proof of concept, right? Because as you're going down the design, you need to make sure, at the beginning, say you wanted to build a minivan. When you're done, it better be a minivan, right? You don't want to end up with a pickup truck. So the systems engineers keep managing it to make sure that you're designing it properly. And one of the fun part of systems engineering is they're actually the ones who do a lot of testing of systems to make sure they work. So a systems engineer might go in and mess around with the touch screen on the inside of the car and make sure that everything works, make sure it's easy for the user to use. Maybe they even drive the car and make sure that, it's handling properly, things like that. And that's so that's my example for what a systems engineer would do as you're developing a car. So you can think about it, the more complex a project gets, the more important systems engineering is. Say you're building, a rocket ship, right? That's going into outer space. There's a ton of different things you need to take into account as you're building it. So systems engineers are really important there to make sure everything integrates together well, everything's functional. And something I will also point out that systems engineers nowadays are really relying on software tools to help them with their job. A lot of them create models of what the system will look like before it's actually built. They'll create functional block diagrams, which is kind of a picture of how the system looks, how the different components interact together. You'll also create logic flows that explain what happens in a given circumstance. And they also might do performance testing, which is how math comes into play as a systems engineer. If you're doing calculations on how fast something might happen, or different calculations like that. So that was my quick explanation of systems engineering. And just one other thing to mention on a personal note. So my first job as a systems engineer, we were building basically a fancy phone system that was going into nuclear submarines. And as the new systems engineer on the job, I was responsible for testing the system. So actually, if you're someone who likes going out and touching things and working with it, it was really fun. I went over to the factory where I helped them actually set up and install the first iteration of the phone system, figure out what was working, what wasn't working, test, make calls. Basically, I was trying to break the system to see if there were any issues. So that was a fun first job to really understand how everything works, try to break it. Once you broke it, try to find out a way of fixing it. And that was really fun for me. Okay, so moving on to my later part of my career here, where I started focusing more on cybersecurity. So you can think about cybersecurity. It's a very hot buzzword, right? Why is it so important today? I think it's really because almost all the products that are built today, they're connected to the internet or a network, and they contain computers. You could think about it, a new car that's built today, it has a computer inside of it. A lot of them have Wi-Fi, Bluetooth. They might connect to, one of the cell phone networks. I was working on my house the other day. I installed a new thermostat. It has Wi-Fi. It's connected to my home network. Smart TVs have, they're connected to your Wi-Fi again. Even if you're talking about something that's in a warehouse or a plant, all of the machinery, those all have computer interfaces. People upload software to tell them what to do. They might be hooked up to a network in the warehouse. Anything that you're doing online, you're going onto a website, you're logging in to see something, That's another thing that, where cybersecurity comes into play. So basically, the increase of having things connected to the internet, having computers everywhere, it's basically giving attackers, a wider, what I'm calling an attack surface, right? It's easier for the bad guys to attack systems because everything's a computer, everything's on the internet, right? There's so many different bad things that people can do if they want to, which makes cybersecurity so important, right? So here I'm saying cybersecurity and engineers. So really, these are the engineers who are tasked with protecting products from hackers, making sure that the products that you have in your house on your home Wi-Fi network are secure. If you have a camera in your home that's hooked up to your Alexa or whatever, you don't want someone going in and viewing the camera footage from the inside of your house. You want to make sure that that's secure, right? So you want to protect private user information. You want to make sure that products are functioning as designed. So that means if you have, let's say you have a car that's on, some sort of wireless network, you want to make sure that someone can't change the software in their car. And when you turn your steering wheel right, it's turning the wheels left, right? You want to make sure that it's functioning how it's designed. You also want to maintain availability. There's some attackers who will just bring systems down and make it so they can't work anymore. So if you turn the keys in your car and it just doesn't start because someone, fried your system, that's another form of an attack. And then bring it back up to, securing private user information. You could think about you're logging onto your bank account or checking medical records online. You might have your social security number, very private personal information on there. You want to make sure that people can't steal that information and use it for malicious purposes. So I think that cybersecurity is really an exciting kind of part of engineering. Again, when I'm doing my day-to-day job, I work at Chubb, it's an insurance company. I'm trying to think about, what would a bad guy do if they were trying to attack our systems? How would they try to get into our software products or our website and wreak havoc, on our network? You have to think about all of these attack paths, really kind of come up with a list of issues, figure out what's the highest priority, what's the dangerous issue. And then you need to think like an engineer and find a way where you can plug up those holes and block attackers so that they can't do what they're trying to do. And it's really kind of like an iterative cycle, right? Because, attackers will come up with a path of attacking your system and you protect it, you fix it, but they're going to keep coming up with new ways of attacking. Everything software it's always changing. So you always need to think of new ways of protecting your system. So job's never done and it's different every single day. But I think it's very relevant. It's very fun and exciting. When I was in school, like I said, I studied electrical engineering. I was focusing on, more kind of the hardware side, microelectronics, photonics, and kind of just got into this by chance for my first job. But I'm seeing nowadays that there are a lot of schools that have, minors in cybersecurity. I think engineering is a really good degree to get into, just because it teaches you about, problem solving and the creativity and having the right mindset to be able to, solve problems in your job. So I think that's all I have for my presentation. Does anyone have any questions?
Kira, no disrespect.
Mm-hmm.
I think there will be questions for you, but I'm going to let's just move on so that Judy can give her presentation and then we'll have some questions at the end. This is the disadvantage of going forth is that we're starting to get squeezed. So let's move on. And then we'll come back to you because I've got some questions for the whole group. Our next presenter is Judy Bowen. She is a vice president and senior project manager who manages transportation improvement projects for Greenman Pedersen. She has over 35 years of experience working on interchange improvement and bridge replacement projects in New Jersey. Judy oversees a group of more than 20 professionals who provide highway design, environmental permitting, hydraulic analysis, dam improvements, and safety improvements. She is also chair of the American Council of Engineering Companies Women in Engineering Committee. She earned her bachelor's degree in civil engineering from Lafayette College in Easton, PA, and she has 2 sons, a college freshman and a high school senior. Judy.
Okay, let's see if I can share my screen. Is that working? Okay, good morning. Thank you, Martha. And thanks to the Roebling Museum for hosting this great event. It's unfortunate that we have to be remote today and can't enjoy the Roebling Museum personally, but at least we have this option for us. I am Judy Bowen. I'm the director of the Civil Highway Department for Graham and Peterson's New Jersey office. And as Martha noted, I have managed projects which involve bridge replacements, interchange improvements, corridor studies, safety improvements, etc. So why did I choose engineering? Well, like most of you, I suppose, I was good at math, physics, and science in high school. I really didn't think much about what I was going to major in while I was in high school. I thought about math and kept that option open when I started at Lafayette. I also thought about being a doctor since my dad was a doctor. But my grandfather was my real inspiration. He was an aeronautic engineer. He invented the automatic pilot in airplanes and heads-up flight controls for pilots, which are now widely used in cars. He was incredibly brilliant. He would talk about his work and nobody had any clue what he was talking about. My grandmother would look up from her knitting and say, "Paul, you're boring them." So I realized his kind of engineering was way above my head, pun intended. But I did like the idea of applying math and science to something that I could touch and feel. I chose civil engineering as my major since it seemed to be the most approachable. And I graduated from Lafayette with a BS in civil engineering. Although not many women chose engineering as a major back when I was in college, 1/3 of my class at Lafayette were women, but we had no women engineering professors at that time. But after graduating, I worked in construction for the New Jersey Department of Transportation for a year before moving to design and consulting engineering, where I've worked for over 30 years. So engineering is very diverse. It offers a lot of opportunity and flexibility. Many companies hire engineers, as was just noted, for all sorts of different jobs beyond engineering itself, for management, manufacturing, etc. Because each of those businesses know that engineering majors are problem solvers. Engineering can, of course, be challenging, as also noted, but it's also very rewarding personally, professionally, and financially. It's awesome to be able to drive through the state and see so many projects that were built that I designed or was involved with. The photo in the upper right corner is the very first project where I was the engineer in charge. That's Interchange 89 in Lakewood and Brick Townships on the Garden State Parkway. But no matter what path you choose, teamwork will always be critical. By working together, we're all greater than each individual on the team, and we elevate each other. As indicated in my bio that I wrote, I don't know if it was in there, but I played 2 varsity sports while I was in college, so I was very busy. But I certainly learned time management, teamwork, and leadership skills, which have served me well throughout my career. And similar to Denise's remarks, I certainly didn't realize that I was learning those skills at the time. So I'm going to spend the next few minutes with a history lesson, talking about famous women engineers in history. Being a female engineer was unheard of when these women made their marks in the world, but they were the trailblazers for all of us. I'm going to start with Edith Clark. Edith became the first woman to earn an electrical engineering degree from MIT. She worked with GE from 1919 to 1945, becoming a salaried electrical engineering after 2 years of employment, which was quite an achievement at the time for anybody, let alone a woman. In 1921, she received her first patent for the Clark calculator, a device that was used to solve electrical power transmission line issues. And then she went on to teach electrical engineering at the University of Texas for 10 years, making her the first female professor of electrical engineering in the United States. Of course, I would be remiss if I did not mention Emily Warren Roebling. She was the early champion for breaking the glass ceiling for women in STEM fields. She's best known for her contribution for the construction of the Brooklyn Bridge, which was completed in 1883. So her father-in-law, John Roebling, developed a way to make strong, flexible wire rope and began building suspension bridges, and later established a company to manufacture the wire ropes in Trenton. We talked about where that is right now, earlier today. Following the Civil War, the New York Bridge Company hired Roebling to design the Brooklyn Bridge. As construction started, there was an unfortunate accident and he crushed his foot. He died of tetanus shortly after. His son, Washington Roebling, took over as the chief engineer. His father had sent him to Europe to learn methods for sinking foundations. He immediately began work on the foundations when he took over for the two towers, and was working at the bottom of the caisson foundation and was exposed to hours of compressed air. When he was able to, he actually got the bends and was unable to work and was bedridden. Emily Warren assumed responsibility for all of the work and was on site all the time and was his liaison with the engineering team to keep the project moving forward. Although he would watch construction from a telescope, she was carrying out all the day-to-day project management, managing technical issues, managing the materials, doing stress analysis, overseeing construction and calculations, and she was the standing leader for the bridge's construction. Everybody on site assumed she was the chief engineer, and actually she was. But all the while, she was an advocate for her husband, so he would keep the title as the original chief engineer. And upon completion of the bridge, she was the first to cross the bridge, acknowledging her instrumental role in its success. And my company, Graham & Peterson, recently initiated the Emily Roebling Award, and Denise Carter, who you all met today, was the very first recipient. And I have to note that Martha Moore, our talk show host today, is a descendant of John Roebling's son. Moving right along, next is Hedy Lamarr. She's better known as a movie star in the 30s and 40s, and she's best remembered for the first woman to wear it all in one of cinema's first sex scenes. But she proved she was much more than a pretty face. She was a prolific inventor. When taking time out of her acting schedule, she shattered stereotypes by using engineering to invent a system for the US military that was the basis for the design of torpedo guidance systems. She transmitted radio signals along rapidly changing or hopping frequencies, which were used for American radio-guided weapons, which were more resilient to detection and jamming. It's this frequency hopping theory that formed an unbreakable code. Her invention was top secret, but the Navy didn't use her invention, saying it was impractical. They suggested that perhaps she could help the war efforts more by using her beauty to sell war bonds. She did sell war bonds, but her frequency hopping patent expired before it was unsealed. But it is the technology. The technology is the building block of Bluetooth today. Next is Oliver Dennis. She was born in 1885. And as a child, she was always building and tinkering with things. When she was just 10 years old, her father gave her a set of tools and she built a scale model of a streetcar for her younger brother. It had seats that turned over and steps that moved up and down. So cool. She earned her bachelor's degree from Goucher College in Maryland, and then her master's degree in math from Columbia, and then taught high school math for 10 years. She never gave up, though, on becoming an engineer. So she went back to school and became only the second woman to graduate from Cornell University with a master's degree in civil engineering. She went on to work for the B&L Railroad, building bridges in rural Ohio. She said, "I helped lay out the railroad line in Ithaca last December, and I'm rather anxious to get out on the road again. There's no reason that a woman can't be an engineer simply because no other woman has ever been one. A woman can accomplish anything if she tries hard enough." Soon after, she was promoted to Engineer of Service, a position the company created for her. Her role was to develop ways to improve the passenger service and trains so they could better compete with cars and city buses that were starting to become more common in the 1920s. She also contributed to passenger comfort in various ways. She invented a patent for the Dennis ventilator, which was in the windows of certain cars and could be controlled by the passengers. She played a major role in air conditioning the coaches, dimming overhead lights, reclining seats, and stain-resistant upholstery. She put the civil in civil engineering. No details were too small. She worried about dressing rooms, dishes, dining cars. She would puzzle over every one of the details. She became the first member of the American Railway Engineering Association, and she spoke to groups about her life and career, encouraging other women to pursue their interests. She said, "No matter how successful a business may seem to be, it can gain even greater success if it gives consideration to the woman's viewpoint." Next is Nora Stanton. She was born in England, but as a small child, she moved to New York. In 1905, she became the first woman to graduate from Cornell with a civil engineering degree. That same year, she became the first female member with junior status of the American Society of Civil Engineers. After graduating from college, she worked for the American Bridge Company and for the New York Board of Water Supply. While taking some classes in electricity and mathematics at Columbia, she worked as a research assistant for Lee DeForest, who invented the radio vacuum tube. They eventually married, and Nora worked for his company until 1909, that'd be long. He had given her an ultimatum to either be his wife or an engineer. They divorced in 1912. Nora returned to New York City and worked as an assistant engineer and chief draftsman at the Radley Steel Construction Company, and she also served as assistant engineer for the New York Public Service Commission. In 1914, she began working as an architect and developer on Long Island. She then applied to ASCE for a full membership because she had aged out of the junior status, but her request was denied. She filed a lawsuit against ASCE, which gained notoriety despite the fact that she eventually lost. She was a fierce advocate of women's rights and was politically active as she was an engineer. Next is Hertha Ayrton. She was a mathematician. She was an inventor, a friend of Madame Curie, and she was also an outspoken advocate for women's rights in science and in the voting booth. She invented the Ayrton fan, which dispelled toxic fumes for World War I trenches. And she worked on researching how you see in London, the lights would flicker on and off in the early parts of the 1900s. She did research that it was oxygen coming into contact with carbon rods, which created that arc. But she was best known not only for the work on electricity and her gas fan, but also for women's rights. So now I'm going to step out of the past and into the present. We get color. First is Rosina Bacci. She's a specialist in robotics research. She has her MS and PhD in electrical engineering. She was an orphan because all of her family was killed by the Nazis in 1944. And she moved between orphanage and foster parents. She was always an incredibly good student. She was determined to have a career in electrical engineering, and she earned her MS degree and PhD degree in electrical engineering. Shortly thereafter, she was invited to study a new discipline of computer science at Stanford, so she came to the United States. She stayed in the country for 1 year, or she planned on staying for 1 year, but then she heard about an invasion in the Russian invasion of the Prague, and she decided to stay. She remained and got her PhD in computer science. For the next 30 years, she worked as a professor at University of Pennsylvania, and then she moved on to Berkeley, and she is where she was professor and chair of computer science, College of Engineering. Her research continued over 50 years, and she is now a professor emeritus. Ellen Ochoa, she's a veteran astronaut. She was chosen for 4 space flights and has almost 1,000 flight hours to her credit. She was the first Latina selected as an astronaut and was director of NASA's Johnson Space Center, the second woman to hold the title and the first Latina. She is now chair of the National Science Board, which establishes policies for the National Science Foundation and advises Congress and the White House. She also holds 3 patents on optical systems that can be applied for multiple uses, including in space. She didn't dream of being an astronaut when she was a youngster because it was in its infancy. But when Sally Ride was chosen to be on the crew, it made the opportunity for women expand. NASA was obviously very competitive. She applied 3 times before she was accepted. Of note, she's also a classic flautist, and she took her flute with her on her first mission to space, which I thought was pretty cool. Gwynne Shotwell has her BS in mechanical engineering and her MS in applied mathematics. When in high school, she was a good athlete, and a good student, but she didn't really know what she wanted to do. She wasn't interested in engineering until her mother took her to a panel discussion where a mechanical engineer inspired her to become an engineer. I hope one of us, 5 of us, is that inspiring. So she interviewed after graduating with IBM. It was the day of the Challenger space shuttle disaster. She was so shaken by the disaster, her interview didn't go well and she wasn't offered the job. But she began her career then with Chrysler in the management training program, but she became bored with it and she returned to Northwestern for her graduate degree. She then moved to aerospace after 10 years with Aerospace Corps, a think tank focusing on military space research and development. She had an overwhelming desire to build spacecraft. In a letter to a rocket manufacturing company called Microcosm. In 2002, she met Elon Musk and joined SpaceX. She was a 7th employee. Today, she's president of SpaceX, and she won the 2011 World Technology Award for Individual Achievement. And she was, in 2012, appointed to the Women in Engineering Technology Hall of Fame. She regularly speaks to businesses. In 2018, she gave a speech called Launching Our Future. She discussed her vision for her industry, but also why diversity and inclusiveness of women are necessary to advance our society. Barbara Oakley, very interesting person. She's known to say a good teacher will leave you educated, but a great teacher will leave you curious. She's a professor of engineering at Oakland University in Rochester, Michigan, and she's involved with San Diego State's Learning How to Learn program. She is a writer and a teacher, and she's I'm going to bring one thing out. There was a question before. Do you have to be a good student to be an engineer? The books she's written are Learning How to Learn, A Mind for Numbers, How to Excel at Math and Science, even if you flunked algebra, and Breaking Through Obstacles to Learning and Discovering Your Hidden Potential. Others are Learning How to Learn, How to Succeed in School Without Spending All Your Time Studying, a guide for kids and teens. So she has spent her time researching learning skills and STEM education and how they go together. So there are a lot of, actually, I was reading this and I downloaded a couple of books for my younger son who struggles with learning. But she has an interesting career. She spent time in the military. She rose from private to captain in the Army, and she was recognized as a distinguished military scholar. She worked communications on the South Pole and in Antarctica and served as a Russian translator. She is an elected fellow of the Institute of Electrical and Electronics Engineering and the American Institute of Medical and Biomedical Engineering. Roma Agrawal is a very young engineer, award-winning author and broadcaster. She designed footbridges and sculptures, train stations, and skyscrapers. She's left an indelible mark on London's landscape. She designed the spire and the foundations for the Shard, which is the tallest skyscraper in London. And as a child, she was asked, what do you want to do when you grow up? She wanted to be an astronaut, but at some point she thought it's not really terribly realistic because roller coasters scared her. So she dreamed of becoming an architect. But she's probably best known as a tireless promoter of engineering and technical careers for young people, particularly underrepresented groups such as women. She's an engineering storyteller. She presents documentaries. She hosts podcasts and writes books. Her first book was published in 2018, and she also has a children's book out. Roma received the Queen's Member of British Empire Award. So she uses the title MBE for a member of British Empire, but she actually changed it to Mega Badass Engineer. She spends her time with media interviews, and she's been featured on documentaries for her work on the Shard, and she's a top woman tweeter by The Guardian. She promotes engineering, scientific, and technical careers to young people, and particularly to underrepresented groups. She talks to thousands of people, including schools, universities, and organizations. My last person is Jean von Briesen. She's a professor at Carnegie Mellon University. Probably her biggest work, other than being a professor, is she's just absolutely known as the most valuable mentor and advisor, especially to female students. She also mentors the younger professors and professionals within the school and in nearby institutions. She spends her time elevating other people. I can't stress enough the importance of a woman having a woman mentor or somebody to show the way or to work with people. When you go to college, when I was in school, there are no women professors, but I look at different schools right now as I look at schools with my children, and it's amazing how many women are now professors at schools. And it's a great thing for all of you girls growing up and thinking about becoming engineers. So what's your future? I have pictures of some of our presenters today, but all I can say is be bold, take chances. You will make mistakes, but learn from them. Have fun and enjoy the journey. Thank you.
Thank you so much, Judy. That was terrific. I think it is unquestionable that we've had an entire panel of mega badass engineers. Thank you, all 5 of you, for joining us. We've also had through logging into this webinar and asking really interesting questions. There's obviously a whole cohort of great young women who want to come up and be the next generation of engineers. I'm just going to ask one question before we run out of time and everybody has to sign off. And I just want to cut to the chase. You've just documented that it's been a long road for women to get into the engineering profession. What's it like now? Do you fit in? Are you still in the minority? How is it being a woman in the engineering profession? And I want to throw this open to all of you engineers.
I can start. We're still a minority. Very much so. I think we overall, we're about, women in engineering is about 15% of engineers, but it's actually grown dramatically since the early 1980s when I chose engineering. So we're making steps, they're just slow steps. But while it, sometimes people might perceive it as a detriment to our careers, take it and use your differences to make everybody's lives better. People are better for having women on their teams. We heard that in the quotes from some of the women from history, and we can see it now. Many, many companies are making concerted efforts to hire women, advance women, and provide opportunities to women. There's groups like the one that I lead for the ACEC that focuses on advancing women's careers. There's lots of opportunities out there, and I encourage all of you to don't let the percentages deter you from engineering in any way.
Thanks. Do any of our other panelists want to weigh in on this?
I definitely agree with what Judy was saying. I feel like a lot of times I'll be in a group with a lot of men and there'll be something they didn't think about because, I don't know, not to generalize, I just feel like sometimes men can be a little disorganized. And I think being like a woman in STEM gives me like an opportunity to kind of add my opinion and talk about how like I can help in a different way than I think some men can. And also gives me an opportunity to stand out if I'm like, it's me and a few other women. I don't know. I think sometimes it's more noticeable.
I'll just jump in real quick. Judy and I are more or less contemporary. So, you know, from what we've seen from the time when we first started in engineering until now, there definitely have been a lot of strides forward. As she points out, there is a real focus right now to encourage women, like this program, to encourage women in engineering. As a woman of color, you know, there's another sort of aspect of other that I've experienced over the course of my career. It's been especially in the area of construction engineering and construction management, tough group. But, you know, going back again to what Judy said about finding mentors and, you know, kind of finding the people that, you know, will support you, because, you know, not every day is going to be necessarily easy, but, you know, stick to it. It's important that our voices are a part of finding the solutions. And so it has changed a lot for the better. There's still work to do. So, you know, the more of you that get involved with engineering, the better it will be for all of us.
That is terrific. Thank you so much. Unfortunately, I think we have to be true to our word and stop because it's noon. I just want to thank all of our panelists and also all of the young people who logged in and asked such great questions. And I am sure that, you know, in years hence, they'll be on the panel talking to the next generation. So I just wanted to say, let everybody know, we hope that we'll see you at the museum. We open for the season on Thursday, March 3rd. We have some great events coming up. In April is our car show. In June is the garden tour, and more excitement to come. So you can find out all about it on roeblingmuseum.org. This program was recorded and it will be posted to our Roebling Museum YouTube page. So like and subscribe, as they say. And thank you all so much for coming.